Today we will start our next topic that is the function. So last class we have discussed about relations, types of relations. Then today we are going to discuss about functions. Now, if I say function, what do you mean? See, from the earlier class, that means from the very beginning, we are talking about the ordered pair, then the Cartesian product, then you have a concept like relations. Now, today we will introduce a topic that is function. Now, if I say function, the formal definition of a function is a function from a set A to the another set B is a relation f from A to B which satisfies the special condition. What is the special condition? See, here it is given that a function is a relation, but for that particular relation there is a special condition, which is for every element A there is a unique element B in B such that the ordered pair AB is in F. See, in this line it is clearly written that a function is a relation with a special condition. What is that condition? For every relation we have two sets A and B. So here the special condition is for every element of the first set A we have a unique element in the second set B. So it is given that, see, here for that special condition there are some important words. The first is the unique. What do you mean by unique? Unique means, yes, anyone can tell me?
Single.
Single. So single means, see, in mathematics, what is the actual meaning of a unique? So if I draw this diagram, suppose these two A and B, two sets, then a function R from A to set B. Now suppose you have elements A, B, C, D, E, F in set A, that means the first set, and the elements 1, 2, 3, 4, 5, 6 in the set B. Now under this relation R, the image of A, that means the image of A from the first set A is 1. Okay. Similarly, under some particular relation, the image of B is 2. Similarly, image of C is 3, D is 4, E is 5, and F is 6. So these are the particular relations of the elements of A with the elements of set B. Now see, if you look at this diagram, it is clear that, see, A has only one image, which is A, which is 1. Similarly, B has only one image, 2. Okay, and for each element A, B, C, D, they have a particular, that means different images under R in the second set B. Is it clear? See, each one have a particular image, different image. But if you notice this second diagram, see, in this second diagram, what is the difference between the first and the second one? What is the difference between this diagram
A
and
has
this
two
one?
image.
Yes. See, for this particular element A, it has two image, 1 and 2. That means for this case, can you say that A has a unique image? For the second figure, can you say that A has a unique image?
No.
No, because A has two images, 1 and 2. sometimes A may have three images also. For this case, for that, in this cases, see one image, two image, three image, or four image, we cannot say that yes, A has a unique image. But if you consider the first diagram, each element of set A has a unique image in the set B. So the second diagram it does not represent a function. Why it is not representing a function? Because it violates the condition that there is a unique image in B. So in this case, A does not have a unique image. So this is not a diagram for a function. So this is the particular diagram. This particular diagram will represent a function. So always remember this word. Every element must have a unique image. So your diagram will be in this form. So from A, there is only one arrow mark to any element of B. Only one arrow mark. Here from A, there are two arrow marks. So that's why it is not a function. But in the first image, A has only one arrow mark to a particular element in set B. So that's why it is a function. Now, see, there is one more important point is there in this particular definition. So for every element A, so if I say for every element of A, what do you mean? What is the idea for every element of A?
Element of set A.
Yes, for C, each and every one. So suppose this is a set A, this is set B, and there is a relation from A to B. Now, like the previous example, the elements of set A are A, B, C, D, E, and F. And the elements of set B are 1, 2, 3, 4, 5, and 6. Now, see, suppose I have the arrow marks or the arrow diagram like this. From element A, there is a relation to the element 1. From B, 2. Then from C, there is a relation to the element 3. Then from D and 4, E and 5. And the last one is 7 and 4. So, if you have this kind of relation, see, for every element of set A, there is a unique element in set B. And for each element, see, from each element of set A, there is one arrow mark to some element of set B. Is it correct? See, all the elements are related to with some elements of set B. Okay?
Yes.
So in this
Yes, ma'am.
case, we can say that for each and every element of set A, there is one image in set B. So this image will represent for each and every element of set A. Now, so this is our first set. Now see the second one. In this diagram, A is related with 1, B is related with 2, C to 3, then D is related with 4, E is related with 5. But see, F is alone. There is no such relation from F to any element of B. So there is no arrow mark from F. That means we are not getting any relation from F to any element in the set B. Okay, so F is alone. So in this case, it will not represent a function because it violates the condition for every element A in the first set. So for this element F, we are not getting a relation with any element of set B. So that's why this figure will not represent a function. So always remember, for function, you have to get a relation for each and every element of the first set. and the first one is, see, a unique element. That means only one arrow from each element of set A. That means from each element of the first set, only one arrow. Okay. So these two are very important points of function. So suppose in your exam I have given you some figures, like there are four figures. So you have to identify which figure will represent a function. Okay, you may say that this will represent a function. Yes, it is correct, because these elements, each and every element, we are getting a relation with some element from set B. Okay, and see, for each and every element there is only one arrow mark, so that's why this figure will represent a function. Okay, now this point we have already discussed in our previous class, what is a domain and codomain. So here again I am repeating that here the first set is called the domain and the second set as codomain. In our earlier class also, in case of relation also, we have discussed what is a domain and codomain. Is it correct? So here again I have written that the first set of the relation R is called the domain and the second set as the codomain. Now for this example, for this particular figure, can you tell me what is the domain? What is the domain for this particular figure?
A, B,
Set A.
C, D, E, F.
Yes, the set
Set A.
A. So
A.
you can say the set A. So this A set, that means the first set is the domain of this particular relation. Now what is the codomain? Sorry, this is the codomain. What is the codomain?
Set B.
Set B.
Codomain is set B. Yes, correct. The codomain is set B. And what is the range of this particular function? Range?
Set B.
Set
Set B, because for each element of set B we are getting a pre-image. Okay, so this is set B is the range as well as the codomain for this particular relation R. Now a function, we can say sometimes a function can be called as a rule or mapping or correspondence. So, for example, if I say f is a function, or sometimes I may say f is a mapping, or sometimes I can say f is a correspondence. So all these are the different names of function. Okay, always remember, mapping means the same thing as function, correspondence means again the same thing as a function. Now, there are some important notes from the definition of function. So, first is f, that means a function is a collection of ordered pair. Is it correct? Function is a collection of ordered pair.
Yes, ma'am, because it's related to
Yes,
her.
yes, yes. And one important thing is, see, a function mathematically I will write in this form. Small f, such that small f is a function from set A to set B, f of x is equals to y, where x are the elements from the first set A and y are the elements from the second set B. So function we will represent like this: f is f from A to B such that f of x is equals to y, where x belongs to capital A and y belongs to capital B. So if I write this, you have to understand that it is a function. Now this is the first note. I have already explained that f is a collection of ordered pair. Yes, because f somehow is a special kind of relation. Now, what are relation? Relations are some ordered pairs. So, in this way, we can say that F is also a collection of ordered pairs. Suppose we have two sets A and B, and the elements of set A are 1, 2, and 3, and the elements of set B are A and B. Now, can you tell me the ordered pair of the Cartesian product A and B? What will be the ordered pairs of A cross B?
1A, 1B, 2A,
Yes,
2B.
and 3A, 3B. That means from 1 we are getting two relations of the two relations from the elements of set B. 1A, 1B. Again for 2 also I am getting 2A, 2B. For 3 also 3A, 3B. Okay. So F function is a collection of ordered pairs. So in this way, but see, this 1A, 2B, 3B. Why I have not written 1B also? I have only taken 1A. Why I have not taken 1B? So for this question, let us go to the definition of function. So the definition says that F is a function or F is a relation which satisfies a special condition. And what was the special condition? For each and every element of set A, there must have a unique element in set B. So for that particular word unique, if I write 1A again 1B, so it will violate that particular condition that one must have a unique element, unique image. So 1A, that means from 1 I am getting only one arrow mark. But if I draw another arrow mark from 1 to B, it will violate the condition. It is not unique. Is it correct? So that's why I have written only 1A. And the next one is F is always a subset of A cross B. Why F is always a subset of A cross B? This is somehow related with this figure only. Yes?
Because function is under the sub
Ye-
set A and B.
Yes, yes. Because see, if I say that the Cartesian product of A and B, you have already told me what are the elements of the Cartesian product. 1A, 1B, 2A, 2B, 3A and 3B. But here, as a function, I have taken only 1A, 2B and 3B. I have not considered 1B, 2A and 3A. So that's why function is a collection of some particular ordered pair of the Cartesian product A and B. So that's why function is always a subset of A cross B. So always remember, see, these points are important for your exam. So you can write these points. Okay. So first point is F is a collection of ordered pair, and second point is F is a subset of A cross B. Now, she is my most favorite student. She is always thinking something. Now, let's see what she is thinking about this particular figure. She has a question. So, she was thinking that when the function f and the Cartesian product have the same number of elements, because see, in this figure we are getting only three ordered pair for this function f and six ordered pair for that particular Cartesian product A and B. But in some cases, we will get the same number of elements in the function f and the Cartesian product of A and B. Now what is that? What is that particular condition for which we are getting the same number of elements? Do you have any idea? You can think. It may be wrong, okay, it is okay, but you can think. When we will get same number of elements for the particular function and that for particular Cartesian product.
B should have one element.
Yes, when B should have one element. That means if B has only one element A, then the Cartesian product of A cross B will be 1A, 2A, 3A. And for that function f also, we are getting the images like 1A, 2A and 3A. And this function have to satisfy the definition. So what was the definition? That for each and every element, now see, for each and every element of A, that means 1, 2 and 3, we are getting a unique image in set B. That means for 1 we are getting only one image A, for 2 also we are getting only one image A, and for 3 also we are getting only one image in B. So that's why this is a function and with same number of elements as the Cartesian product of A and B. Now see, students, I think only one student is giving all the answer. What about the other students? All of you are clear? See, if you have any doubts, you can ask me. If you have any doubts, because these are some important concepts of this paper. These are very important. So if you have any doubts, you can ask me. Okay. So our last point is, there is one more point. Suppose you have a function f and the elements of, or you can say the ordered pairs of f are like a comma b. There is another ordered pair of f which start with a and c. So ab and ac both are in f. Then see, both the ordered pairs are starting with a. Then there is only one possible condition, and that is the second numbers must be equal, or the second elements must be equal. But why, if a comma b and a comma c are in f, it must be b equals to c? For which condition b equals to c?
Unique image.
Because the image must be unique. So if
Unique.
yes, and if you consider that arrow diagram, from A there must be only one arrow. So if you consider AB, so from A to B you are getting an arrow. Again from A to C you are getting one more arrow, which violates the condition that there must be one unique image. So for that condition, there is only one possibility, that B must be equals to C. Okay. So this is all about your functions, the definition of function. So are you clear about the definition of function?
Yes, ma'am.
All of you are clear? See, if you have any doubt, you can go through these slides, because recording I will share. You can go through the recording. Again, if you have a doubt, you can call me or you can text me. Okay. So this is all about functions. So in our next class, we will discuss some important functions. So first of all, you have to be clear what is a function. What is the definition of function? So today I will stop here. Next Monday we will discuss some important functions. Okay. So I will take the